Carring to have Anne Carring from the University of Chicago with us. Anne has worked a lot on sort of field experiments in low and middle income countries, particularly low income countries. And she's sort of applying insights from psychology to economics and then running very large field experiments in those countries. And today is also no exception. So she's going to talk about Kenya, if I'm correct. She's going to look at sort of social image concerns in the context of deworming. So we're very glad to have Anne today. And the floor is yours for the next hour.
Thank you so much for stepping just to let everyone know that if you have questions along the way, just write them in the chat, and I will stop Anne during during her talk when I find it more suitable. Okay, sorry, Anne, and the floor is yours now. Thanks.
No, absolutely, that's fine. Thank you so much for the introduction, Hans. So yeah, I'm very glad to present joint work today with Edward G, who's a graduate student soon on the market from University of Chicago, and a collaborator, Karim Naguib, who's now at AstraZeneca, but at the time was working at Evidence Action, who was the partner for this large field experiment. And so what we're interested in here is looking at social image concern and thinking about how they might influence optimal policy in the context of community deworming in Kenya. So broadly speaking, this research is motivated by the observation that markets often fail to provide socially optimal outcomes or to achieve them. And governments can obviously shape the economic incentives, like costs and benefits of actions, to realign individual choices to get closer to that social optimum. One of the most powerful tools we have is, of course, financial incentives. However, these individual choices are also frequently governed by social norms. They're embedded in a social environment, meaning they also carry social image cost and social image benefits. Now, we have a myriad of evidence at this point, I believe, that demonstrates that people are motivated to take visible actions in order to signal that they're a good person, a good citizen. So we have field experimental evidence on voting, on charitable contributions, on students' efforts on test taking, and some of my own work showing how powerful these image concerns can be even in the domain of childhood vaccines. However, there's a separate prediction beyond that that sort of says these types of social image motivations can actually meaningfully interact with economic incentives and can actually dampening or potentially strengthening the effects that economic incentives might otherwise have. So if this is true, then we're not just intellectually interested maybe in understanding that, but even more practically speaking, governments would want to know about this in order to leverage potentially these interactions for optimal policy design. So let me walk you through an example that I hope will crystallize the mechanism that we're interested in this paper. So one of the concurrent examples is that we care about reducing CO2 emissions or increasing the amount of clean air that we have. One way of doing that is accelerating the adoption of electric vehicles. And what the government can do in order to do that is it can subsidize purchases of electric vehicles. Now, however, at the same time, we might assume, it doesn't seem too implausible, that driving an EV also signals that you're an environmentally conscious person. So what we'd be interested then in this example is thinking about, as the government introduces a subsidy for EVs, what will naturally happen is that people who would otherwise not have adopted an EV and may not be as environmentally conscious are going to start buying an electric vehicle. So they have a lower valuation for clean air. And hence, driving an electric vehicle sort of has less of a social image benefit for the people who are driving it now as the subsidy is implemented. So it reduces, the subsidy could lead to a reduction in what's non-financial benefit normally from driving it, which is the signaling value to others. So this is one case where it could moderate the actual efficacy of the financial subsidy. And the way we're going to refer to this, and this is very much taken straight from the theory from Roland Benabon and Jean Tirole, is a social multiplier. So introducing some sort of economic incentive or cost could have additional knock-on effects on the efficacy of that by changing the social returns to the action. So the research question we have then in mind in this paper is how do changes in economic incentives interact with social image motivations, and what does this mean for optimal policy at scale? While there is an emerging theoretical literature, we believe that there is generally, or we think there is a lack of empirical evidence because it's quite difficult to answer this question. You would need to randomize both economic incentives and social image concerns and do that at a community or group level. Since the mechanism that we have in mind here is one where, due to the introduction of an economic incentives, we change who is taking the action versus not, and therefore beliefs over who is taking the action or not type inferences will change. And so you have to do that at a group level. So just for anyone in the audience right now, your mind might go to, oh, crowding out or crowding in terms of monetary incentives might sort of dilute social image concerns. That is not what we have in mind in this in this paper. I only put like two very popular papers down, or a set of authors who've been working on this. So we're not thinking through the lens of a material reward will potentially dilute your signaling value. We're thinking about it very much in terms of shifting equilibrium beliefs about who are the types of people who are taking the action, who are not. And I hope that will become clearer when I walk you through the theory. So what do we do then concretely in this paper? So we're going to try to answer this question in a setting of deworming treatment in Kenya, where the objective from the government side was to increase the take-up of deworming treatment among adults. So the paper sort of has two parts. On the one hand, there's an experimental part where we are trying to create experimental variation in the cost of deworming. And we're doing this by varying the travel distance that people have to take in order to receive deworming treatment. So how far do they have to travel to points of treatment for worms? The second thing then, as I said, what we need to exogenously vary is social image concerns. And how do we do that? We introduce two different types of signals, verifiable signals of having dewormed. On the one hand, we're going to have colorful bracelets that people are going to wear around their wrist, receiving conditional coming for deworming. And another thing is a more familiar technology, which is ink on the thumb, normally commonly used for voting in this type of context. And then thirdly, we need to create common knowledge about the cost of deworming as well as the access of these signals and their meaning in order to shift people's beliefs about take-up. And so we have to implement this experiment at scale. And the way we're doing this is we're going to randomize 144 points of treatment for deworming and their entire catchment areas into different types of incentives, signals, and some placebo group, as well as in different kinds of distance conditions, how far people have to travel. So in total, this experiment was targeting 200,000 adults. In the second part of the paper, in order for us to get closer to quantify and identify these interactions and also then use them and learn about their meaningfulness for policy, we're taking our data to the theory and we're building a structural model to directly estimate these endogenous responses of social image returns to changes in travel distance and to estimate the social multiplier term. Then once we're equipped with that, we want to solve for the policymakers' problem, which in this context, the way we're thinking about it is, how do you optimally allocate the points of treatments subject to achieving a certain target level of deworming take-up? And in order to do that, we're going to combine our parameter estimates from the structural model with actual geographic data on communities and possible points of treatments in this space. And we're going to solve and for different counterfactuals of what will be the optimal allocation of points of treatments. Now, let me quickly summarize what we find in the paper. So the first two findings are referring to the reduced form, like the experimental findings. First, what we show, and that is, I think, has been shown over and over again in the literature, is that people are highly sensitive to changes in distance, which here is the main cost since deworming treatment as such is free. And so increasing distance by 1 kilometer or 0.6 miles leads to a decrease in take-up by about 16 percentage points in control communities. Secondly, same as in some other literature, we find evidence of social image concerns being meaningful, in that in the presence of having access to bracelets, deworming take-up increases from 34 to 41%. And when thinking now about our interest of the social multiplier, how these social image returns might change with distance, we find that these treatment effects for signals for ink and bracelet are twice as large at far distances. Now, moving to our structural model, we're finding a social multiplier consistent with theory that is less than 1, which means that the direct effects that costs normally would have on take-up is dampened by increases in social image returns for signaling incentives. And we find some opposite effects in the control condition that gets more nitty-gritty, and I'm going to talk about later, but this is one main takeaway. And then fourth, when thinking about optimal policy, to what extent are these individual behaviors meaningful when a policymaker is making decisions? We find that accounting for these interactions between travel distance and how social image returns change, a policymaker could locate points of treatment 11% further away. And that effectively means when you can space out points of treatments more, that you could serve a larger geographic area with the same number of points of treatments and therefore expand the program, basically. You could save costs. So in the next steps for the talk, I'm going to give a little bit more information on the empirical context, then very briefly introduce what is sort of the economic theory that underlies the experimental design, and then also later the structural estimation. Then introduce the experimental design and the reduced form results, and then present some of the results from the structural model and going to the optimal policy. So in terms of the empirical context, we're looking here at soil-transmitted helminths, so referring to intestinal worms that are transmitted through contaminated soil. This is a big public health challenge globally. 2 billion people are infected with these types of worms. And the way to think about this sort of in an economic context is that deworming is a public good. For most individuals, and we're thinking of adults here taking up deworming treatment, the returns to deworming are actually quite low. In a sense, they may not be severely impacted as adults in their health from having worms. But most of the benefits are social in a sense that them not having worms means the transmission to children is going to be reduced. So this was one of the motivations why, we have all these school deworming programs, but there's an existing reservoir among adults that leads to current reinfection and how to tackle that. Then I should mention deworming drugs are safe. We don't need to test someone or diagnose them with worms. In the areas we're working in, generally people should be taking deworming drugs, but there's no side effects. All of us could take a deworming drug right now, and it's generally recommended every 6 to 12 months in high infection areas. So particularly in the area where this experiment or this research was implemented in Western Kenya, worms are endemic. So that means there's an infection prevalence at the time where we implemented that was over 20%. Deworming is not a novel technology as such. The Kenyan government deworms children for free in schools. And as you can see from our baseline survey, 78% of adults reported to know about deworming treatment. For adults, deworming is available at pharmacies or at clinics for roughly $1.5. Then when thinking about experience that individuals had before this program that we implemented, the majority, 69%, would say they have taken deworming treatment before. Yet, it's heavily underutilized when thinking about the frequency at which it should be taken in this area of high prevalence. It's a high risk area for worms. Only 38% of individuals reported, and this is self-reported even, to have taken deworming treatment in the last 12 months. Another important aspect to mention here, as I said, there are large externalities. But generally speaking, that's not how the majority of people think about this health behavior. And I think that mimics very much how a lot of people in the world thought about vaccines prior to COVID. Most people thought about this as a private health decision, whether I'm going to get vaccinated or not. And here we've elicited this in multiple ways and simple ways. People generally don't have top of their mind how much they're going to affect others by taking deworming treatment or having worms, or vice versa. And then another key aspect, as we're thinking about working with social norms here, giving the opportunity of making a health behavior visible, less than 2% of adults do believe that deworming is only for sick people. The general belief is that deworming is something that everyone can take, not just children and adults, and it's independent of whether you're sick. Then here I'm showing you some direct evidence now speaking to potential social norm concerns. So what we elicited at baseline is, how do people, sort of through scenarios, how would they praise someone or they would look down upon someone, conditional on that individual in their community, having taken an action or not? And we wanted to benchmark, which you see as a third item on the right, which is deworming or not deworming during a mass deworming campaign. We wanted to benchmark that to some other familiar health behaviors, which is immunizing or not immunizing your child, or another thing that's of interest, which is using a latrine or open defecation. And on top, what you see was sort of more of a placebo or like a behavior that wasn't like a health behavior, which is wearing or not wearing nice clothes to church. So what you can see on the left when thinking about praise, you can see that there's people would self-reportedly say if someone participates in that, they would praise the person, they would give them kudos. Also, not too, quite a few people reported that they would praise someone wearing nice clothes to church. Like there seems to be overall, general positive social norms around all of these behaviors. But when thinking about stigma, this looks quite different. Not wearing nice clothes to church, you can see only like 25%, let's say, they would look down on a person, but not taking part in a deworming campaign. Close to 70% of people were saying they would look down on someone, which is comparable to what we see for not immunizing your child. Open defecation is higher than that. But sort of in the ballpark at baseline, it seems like people have social concerns about what other people should do or judgments. I'm going to pause here for a moment in case there are any questions. Otherwise, I'm going to step into the theoretical framework.
I do have a question.
Yes,
Anna?
and there is a question by Hans. COVID had devastating effects on school attendance, and many kids never came back to school. Did this have an effect on deworming? Could you ask? No, sorry. Did this have an effect on deworming?
I certainly would have had an effect on the implementation of deworming programs, but I have not been able to catch up with evidence actually in terms of, to what extent we have captured that meaningfully set back gains in deworming. So just to be clear, we implemented this experiment prior to COVID. So we were not collecting data post-COVID or during the COVID period. This experiment was implemented actually in 2017. And as far as I'm aware of, actually now really wonderfully in the area we were working, the recommendation for, I think GiveWell has been scaled back to support there, like worms have significantly gone down, like in this area we're working now. So that's a good achievement. But I can't personally comment on exactly what happened with COVID. All I know is that health activities were shut down.
Thank you, Anne.
And this applies to vaccines as well, like, regular campaign activities were just interrupted in the other areas where I work with vaccination for children. Then let me go ahead and kind of give a general idea of, theoretically speaking, how do we think about social image concerns as an individual makes a decision here? So we're going to directly build on Roland Benebow and Jean Tirol's framework of pro-social motivations and incentives. And so we're thinking about an individual's utility, which you see on top here as having broadly two components. The first one is your net private benefit, which is going to be, and so to be clear, the activity here is deworming or not. That's the decision that an individual has to make. And so the net private benefits are on the one hand, your health benefits or any financial or consumption incentive you might receive. And on the other hand, you're going to have there's going to be a cost, which in our context is going to be, you have to make the time and the effort to travel to a central point and take deworming treatment. And then the third component in there is something that is the heterogeneity, sort of how people might very much vary. They may have different intrinsic motivations. The way we're thinking about this here is of how health conscious you are, or from our qualitative data informed, people would say how responsible you are for your health, or how good of a citizen you are participating in these kinds of campaigns. And that type of intrinsic motivation, your type, contributes to your utility, meaning people who have a higher type are generally assumed to be more likely to take up deworming treatment. But it is something that's not observed by other people. People don't know what type of person you necessarily are. And that is where the second term comes in the utility function here, this this expectation term indicated, which is you might directly care about the expectations that others, like negative I, are going to form about your type. And the way they can do this is they can potentially learn from your actions about your type, given that people who have a higher type are more likely to take that action. So there is some link mapping between actions and types. And based on that, they can learn then, and you might care about that. And that's indicated by the parameter mu in front, which is the combined of, well, this is only going to be active in your decision making if there's some visibility around your actions. So this is little x, there's a probability of how observable your actions are. And that's something we can directly experimentally manipulate. And then secondly, how much you actually care about your social image in that context. And that is an empirical question, depending on how strong these social image concerns are, that will sort of lead to stronger or less strong treatment effects, or any at all. So that is sort of the setup when thinking about people's preferences in this context. And then when thinking about what is the equilibrium solution here, or how do we find out whether, how people are making decisions in this context, is it's going to be pinned down by a fixed point. I'm not sure how technical people are in the audience, and don't want to go overly technical. But in essence, each individual makes a decision taking the other people's actions as given. And there's going to be one person who's the cutoff type that is pinned down by this top equation here, who's basically indifferent between taking deworming and not taking deworming. And the key component here is this last term, which I indicated as social image returns, which is the next line you can see, is the difference between the expectations individuals are going to form about you when you don't take the action versus if you take the action. So that wedge in expectations is going to what gives you the additional return and utility from taking the action. Now, what I'm describing here is basically saying there is an additional benefit in your utility function if you're able to separate yourselves sort of from the bad apples and you're the good apple, because people think it's a highly honorable thing to take that action. However, what we're interested we're more interested in this paper beyond that, I think there's a lot of literature just showing social image concerns at bite, is kind of saying, okay, well, how does that then interact with a change in the cost, the economic cost of the action? So what you see on top here, I can write down aggregate take-up as a function of cost, which is just 1 minus the CDF evaluated at C, or as a function of C, and that's evaluated in this point at the cutoff type, who's indifferent between taking the action or not. And when I'm now thinking about a marginal change in cost, what's going to happen is, as you can see in this derivative at the bottom, you can see on the one hand, intuitively, if I increase the cost, some individuals who were just on the margin are going to stop taking the action because it's no longer beneficial for them. So you see, the PDF here, but then you see a second term, which is the inverse of 1 over 1 plus the derivative of the social image returns, which means this cost change has a knock-on effect, which is, since it is changing the person who is now marginal about taking the action and not, it means it changes the inferences that are going to be made, who is taking the action versus who is not taking the action. And this is the key by this is the social image returns. And depending, if there were if there was no visibility in actions, this term would just be 1. So there would be no additional knock-on effect. But if the denominator, depending on whether this denominator is basically greater or less than 0, then we're going to get an additional effect that either amplifies or weakens the direct cost effect. So intuitively, the way to think about this, if this derivative is less than 0, not intuitively, just like mathematically, that means that the entire term is going to be greater than 1, meaning people are going to be ending up being more sensitive to changes in costs and benefits. They have an amplification effect. If the derivative is greater than 0, then the term is going to be greater than 1, the denominator, and they're going to be overall less sensitive to changes in costs and benefits. It's mitigating. And the way we can think about this more intuitively, this is again borrowed from the theory straight, is like this graph at the bottom demonstrates how these things sort of move. And so on the x-axis, I'm plotting the cutoff type, but the way you can think about that is the level of take-up. So we can think about different behaviors have different levels of take-up and equilibrium. So if the cutoff type is very high, that means very few people are taking the action. This might be a very admirable act. And if the cutoff type is very low, that means almost everyone is taking the action. We think about it as a respectable act. And so on the y-axis, what you see is the social image returns, and their basic prediction here is this nice U shape. So as you're going further to the extremes, basically social image returns are increasing as the actions are going to become more informative, either about, the most honorable people or the worst people kind of. And so more stigma concerns are rising, or effects of honor or admiration are rising. So this is sort of the underlying thinking of that motivates this experiment in our subsequent estimation. So now let me show you the experimental design that we implemented. So generally speaking, we worked with the government in Kenya and its county governments, and we provided free deworming treatment to adults in a new kind of community campaign. And this was across 3 counties, Busia, Siaya, Kakamega, and Western Kenya. And we worked directly with community health volunteers. So the deworming treatment wasn't provided by researchers, but it was provided by individuals who live in the community and are commonly in charge of supporting campaigns or giving health advice. This was implemented over 12 days. I can say from why as well. The idea here is that within a short amount of time, you want to get as many individuals dewormed as possible in order to discreetly lower the reservoir of worms. So this is Monday to Sunday, 8 a.m. to 5 p.m. And another important effect here is that these community health workers informed individuals before deworming treatment was available about the availability of treatment, where they could get it, the time, as well as importantly about the types of incentives that would be given out or how far they had to walk, where to go, such that people, before making their decision, everyone had knowledge about what was the costs and benefits here. So then there are the 2 experimental treatments. So on the one hand, we wanted to change the cost of the action. And the way we did this, as I said, since deworming treatment itself is free, is the key decision here is the travel distance. How many points of treatments am I going to set up? And therefore, how far people have to walk in order to pick up deworming treatment. And so here I'm showing you the map of the geographic space that we were working in, the 3 counties. What you can see here is about 1,500 primary schools. And so the way we thought about the distance randomizations and these point of treatments is we wanted to use primary schools as an anchor for where people could get deworming treatment in order to have a known location that people would be familiar with. And so what we did is we ran an algorithm such that we could fit 144 points of treatments into this geographic space that would be anchored around primary schools. And we would have around every point of treatment, we would have a sufficiently large radius such that communities, wouldn't switch to another point of treatment, and the point of treatment we assigned to them would be their closest point of treatment. And we could select a community in there that is between 0 and 2.5 kilometers away from the point of treatment. So in the end, what I'm showing you here is, I haven't actually, let me show you first the second point of the second type of randomization we did, and then I'll show you the 2 together. In addition to distance, what we then introduced is at these points of treatments, people were given different kinds of incentives in order to manipulate social image concerns. So on the one hand, we had 2 signals, the bracelets, which you can think about if you look at them, they're very visible, very shiny. They said treat worms and improve the health of your community. But as you look at them, you might also think, well, actually, they're probably might have some consumption value. People might just really like them because, they're bracelets and respond to them. So the NGO really wanted to try something that kind of has no private valuation and no cost to them. And we therefore also introduced ink. Ink is, as I said, commonly used for voting in Kenya. So people can't vote twice. And so we also introduced ink on your thumb. We used a different color than is normally used for voting. We used green, the same as we had with the bracelets. And then we had a control group where no incentives were given out. So people came for deworming at their point of treatment and didn't receive anything. And then we wanted an appropriate comparison group to the treatment arm where people were giving these small bracelets. And there we wanted to have a consumption item that is of similar value to people, private value, but has lower visibility. And so in this context, individuals have a lot of wall calendars on their walls of their houses. So we went for something that's rather light and easy to distribute, and we were giving people out back then calendars. So then putting those two things together, what we ended up with, we had in each of these, 144 points of treatments divided by 4. So around, 35, 36, 37, 38 points of treatments. And each of those were, again, for each incentive condition, split in half, such that we had half points of treatment that were far away. You can see that here in the blue distribution. So in the control group, there were roughly 17 or 18 points of treatment that were located far at a distance of on average 1.25 kilometers. And then the other half of the points of treatments in this incentive condition were located close, which was about 0.75 kilometers and 1.75 kilometers. So the randomization in distance achieved a difference in distance between far and close locations of about 1 kilometer or 0.6 miles. So those are our two experimental treatments. Any questions on that at this point? Otherwise, I'm just going to briefly talk about the data source.
No, there are no questions.
Okay,
thanks.
Then I hope it's clear. Okay, so there was a lot of data collection that went into this. We did a comprehensive household census in all these communities of around 38,000. More than 40,000 people, because we wanted to identify all the adults who would be eligible for deworming treatment. We need and collect geographic coordinates so we could directly map out the distance. I'm going to use distance in the rest of this, in the future part of the presentation, continuously, meaning we exploited like fine-grained distance variation. And then another point that was really important to us, if you look at the third bullet point, we didn't want to rely on self-reports. So what we did is from the sample of adults that we had listed, we picked a random subsample of about 10,000 adults whose deworming take-up we directly monitored at the point of treatments, meaning there we did more intense involved checks of like, what's your name, what's your age, in order to directly identify whether link them, whether a person did or did not come for deworming treatment. So our main outcome is not going to rely on self-reported data, but it's going to rely on, carefully collected data at the point of treatments. And then we have an end-line survey that we implemented about 2 to 12 days after the deworming campaign was implemented in order to verify the implementation, knowledge of individuals, but also importantly, how visible these different incentives were to individuals, and therefore how much people were able to learn about other people's actions. So in the reduced form, what we're doing here is very simple, which is running a linear probability model where the outcome variable is going to be whether an individual in a community took up deworming treatment or not. And we're going to regress it on the binary indicators of the different incentive treatments, as well as for now on the randomized distance far and close. And we're going to interact the incentives with the distance conditions, since we are interested in potentially how the effect of these incentives differs as we're changing costs. And we have some controls we're controlling for, this is Lasso selected, cement floor, gender, phone ownership, and age. And I should say standard errors are clustered at the unit of randomization, which is the point of treatment here, or the community that we selected, since we have one community per point of treatment. So what I'm showing you first here is if you focus on the blue bars, I'm just showing you the levels of deworming take-up. The key aspect here when thinking about this theory is that there's a prediction as economic cost, there are changes in cost, and therefore changes in equilibrium level take-up. It changes people's inferences, beliefs about who is taking an action, which then has knock-on effects. The first stage that we need here is a meaningful shift in take-up. So what I show you here is in the control group in blue, the levels of take-up in close communities and in far communities. So as you can see, in close communities, we're approximately at 42% take-up, and we have a drop by 16 percentage points down to 26% when moving to far communities. And importantly, this isn't just in behavior, but people also, as we elicited their beliefs at endline, in far and close communities, their belief over the share of people in their community who took the action, the difference was about 13 percentage points difference. So very similar to what the actual difference was in take-up. The people realized fewer people were coming. And now the second set of results is looking at the average treatment effect. So what I'm showing you here is 3 panels. I'm showing you on top the combined treatment effects, meaning I'm ignoring for now distance. I'm just pulling close and far communities, and I'm looking at the treatment effects of the 3 incentives compared to the control group. So what we can see is that bracelets had on average the largest effects on increasing deworming take-up by about 7-8 percentage points. Calendar had a small positive effect, but in the reduced form, not significantly, that we can detect about 2-3 percentage points. And to our surprise, this is not something we had anticipated, but ink had actually mostly like a quite negative effect on take-up. The way that we rationalize this, or what anecdotally, not rationalize, but what we've learned is sort of like people perceived it as messy. But on the other hand as well, an election was the year after. So that I think what we learned from this, it's not easy to just move signals across domains. If a signal is commonly used in a domain of voting, moving that into health might actually backfire, that people are more hesitant to take that action because they don't want to have their thumb inked. So now, looking at how these treatment effects vary by distance, first I want to draw your attention to the calendar incentive. And what we can see here is, regardless of whether communities were located far or close from the point of treatment, the effect of the calendar is very stable at around 2-3 percentage points, by which it increased deworming take-up. A different image emerges when we look at the bracelet and the ink, the signaling incentives. Qualitatively, what we're seeing there is a shift to the right in terms of treatment effects of far communities, meaning effects are more positive, or for the ink, less negative. And so we have differences of about 5 to 7 percentage points difference in deworming take-up between close and far communities. I should say, given this is a cluster level randomization and fewer clusters that we have in each treatment, we're not powered to pick up the difference in difference effects for the individual signals. But what we can do in the paper is we can pool the signaling incentives, their treatment effects comparing far and close, and compare it to the non-signaling effects. And then we're able to pick up significant differences in the reduced form. I think there's a question. I saw that.
Yes, there is one.
Correct? Okay.
Yes. Why bracelet and calendar are interpreted as signals and not as gifts?
I think they can be, they are interpreted as, they can be interpreted as a gift as such that you receive when you come for deworming. Signals, in a sense, the question that we're having here is, they are to different extents making behavior visible. And I'm going to show you in a moment that the bracelets made the deworming decisions of other individuals in your community significantly more visible, observable than the bracelets, than the calendar. So there is a significant difference that we can detect by asking individuals to what extent they know about other people's deworming decisions. So signals, in a sense, I think the definition here is they need to be meaningful in a way that they're increasing the visibility of your action. They're giving you an opportunity to, credibly show to others you've taken an action. And people need to be able to interpret that incentive as being linked to deworming. So that's actually the case for all of them. I mean, we in the endline asked, people understood that these incentives or these gifts were given to deworming. And then really the interpretation of social signals comes from the fact of saying, hey, they meaningfully change people's behavior, and we don't think it's driven by consumption incentives or gifts. And I can give you a little bit more information on this in a moment. If someone is concerned, this is just about people like bracelets, if that makes sense. So let me then maybe, is there another question? Otherwise, I'm going to kind of maybe spend a moment on these maybe alternative mechanisms or interpretations that we might have of these incentive effects. Okay, then I move on. So one question that we might have is, or concerned about, is like, were the bracelets more valued just privately as a gift, let's say, than the calendar was? And could it be that there is an explanation for why bracelets might actually be more valuable at far distances? And is that just what could potentially explain why we have larger treatment effects of bracelets in far communities? So an additional thing that we implemented in the study is we actually implemented a willingness to pay exercise, where in the control group, at the end of the experiment, we offered individuals to either receive a calendar or a bracelet gift of their choice, and then offered them a random amount of money between $0 and $1 to accept the opposite gift of what they wanted. So this gives us a sense of like, how much do you value, or what's the difference in terms of money in your evaluation between calendar and bracelet. So I'm just showing you, coarsely, the results here, but basically at 0 Kenyan shillings, meaning like if you were just given the choice between a bracelet or a calendar, 75% of people prefer a calendar to a bracelet. In control communities where these items were not having a meaning in terms of being linked to deworming. They were just offered to you at the end line saying like, do you want this item or this item? And then we had to offer people on average like 45 Kenyan shillings, 45 cents, in order to be willing to switch away from a calendar to a bracelet. And so this is the utility difference that we're estimating here. And then secondly, what we also did is we actually elicited gift preferences across the different distances for people who were. So I can't really tell you about an argument of scarcity in the control communities, but I can, like going to bracelet or calendar communities, I can say, okay, is it the case when fewer people have that item, which is true in far communities, there are fewer people with a calendar or bracelet? Is it the case that people just value the bracelets more? And that's why we see these effects. They just have a higher private value for them. It's not about signaling. So what we did at Endline, we also went back to those communities and we offered people a bracelet or a calendar. We can look at their preferences for choosing a bracelet across distances, and we see no significant differences in terms of their bracelet choice across distances. So, we're trying to do a bunch of things that kind of say the marginal weight of substitution between these, between these incentives isn't differing by distance in a different way. Then another thing you might be concerned about in this experiment is that it could just be that maybe some of these differences in treatment effects are caused by reminder effects. Maybe people are, when fewer people have the item in far communities, they see ink or bracelets, they're just more reminded, or there is more learning going on. And so what we did is we implemented a cross-treatment where a small number of individuals in each community were sent text messages the day before the campaign started, and then every other day, directly reminding them of the availability of deworming and also giving them information about the take-up of deworming treatment of people around them. So sort of like we were directly telling them how many people had already come. And what we find is even in this SMS treatment, this might be a bit overwhelming. I realize this graph, I don't have a ton of time, but what I want you to focus on is just for a moment, the red lines, which is basically the condition where they were given the reminders and information about others. And what you can see when you focus on the red lines, again, these are treatment effects compared to the control incentive groups, is that they qualitatively look the same in terms of treatment effects as the treatment effects looked in the absence of SMS. So meaning when we saturate you with social information about others' take-up or remind you, we're not destroying the treatment effects, meaning this leads us to think that the treatment effects we observe for most of the sample are not explained by reminders or social learning. So now let me go in the last 15 minutes of this presentation and kind of tell you how we're going to use now, this evidence sort of that we have from the experiment in the reduced form and take it directly to the model that I introduced at the beginning. And very simply, what we're going to do here is we literally take the utility function as it was described, the decision to deworm in the theory model, and we're going to try to code it up using our data and model it with the exogenous variation, where Z is the incentives and D is the distance. And we're going to, again, have a private benefit component. We're going to have a signaling component. The main thing I want to highlight here as we're stepping into the empirical world here and we're estimating a model, we're losing the assumption of the theory and we're allowing for an additional margin of heterogeneity, meaning not only do we say people might differ in their type, but they might also have cost shocks or taste shocks. And that's really important as we're thinking about the prediction that I've introduced you before, the sort of U shape of these social image returns, that they're increasing as we're going to the extremes. If you have a lot of shocks, there's a high variance of shocks. What that essentially does, and we allow this in the model, what would happen is this U shape would really flatten and social image returns would fall. Intuitively, if people's actions are actually influenced by a lot of shocks, then the inferences you can make from their action about their type are very weak, meaning there shouldn't be a lot of social image returns, and neither in the extreme should we update more about this being really high types who are taking the action. So this is an important component as we're taking the theory seriously, that we're allowing for an additional heterogeneity here. Otherwise, importantly here, we're basically solving the 6-point equation again in the structural model. Like there always has to be the case when we're having our likelihood function and we're trying to best rationalize the data, the take-up data, with the parameters that we're estimating, private benefit or social image returns. It has to be the case that always this 6-point equation is met. So the nice thing about doing a structural model and moving away, like just running a regular RCT, is we can kind of start being more disciplined and piece these different pieces of data together. So what we're doing now is we're using directly this willingness to pay data because we can learn from that about the private valuation from the calendars and bracelets. And we're also going to start using additional data on beliefs to directly model this mu parameter, which is, as you remember, is about the visibility of your actions. And then all of that, in some sense, is tied together, is moved by the exogenous variation that we have. And we're having some functional form, obviously, that we're putting on here from the model. So let me just tell you, this is another important finding, I think, in this paper, and sort of takes us beyond the standard theory, which is we measured observability and what happened to observability in this experiment. So the way we did this is at Endline, we gave people a random subset of 10 members in their community. And we asked them, do you recognize this person's name? And conditional on recognizing their name, we asked them, do you think this person came for deworming? And the way we're treating this data is basically, did a person report to have knowledge, like either said yes or no, this person came or did not come? Or did a person report, no, I have no idea, I don't know what they did? And what we're finding here is, I'm showing you here on the left-hand side, first of all, the levels of observability, the levels. So therefore you see all 4 conditions, control and the 3 incentive conditions, in terms of the proportion of people that people reported to have knowledge over. And I'm splitting it by far and close. Oh, I think the legend is missing. I'm sorry about that. The blue is far, the levels, and the red is the blue is close and the red is far. So an interesting learning that we had here is in the control condition, first of all, you have very high reported observability about others' actions of people you know in a campaign setting. Like a very short amount of time, a lot of buzz around it. So 75% of people who are close to points of treatments reported to know what others have done. This, however, significantly falls by about 12 percentage points when you go to far communities. People report to have less knowledge, and we're using qualitative data. We ask people how they learn, and then we coded this up using JetGPT. This is a lot of text data. And the concrete distance that we're seeing is there's a lot of learning. If you look at the first bar, we're basically just stacking the reasons of how people learn, and it's either direct observation, communication, because they're close to them, or they make inferences based on personal characteristics. People generally learn a good chunk about other people's actions through direct observation or communication. And that is harder when the points of treatments are further away. In a sense, people report to be less able to observe whether someone went for treatment or there was less communication about the action. So we have this discrete fall in observability as we're moving points of treatments further away. And then what you can see on the right-hand side, I'm plotting the treatment effects now of the different effects on observability. The calendar, going back to this point, gift versus signaling, the calendar did very little in terms of increasing actually the observability of actions. You can see there's no significant treatment effect here, neither for close nor far communities. Whereas both signaling incentives meaningfully increased the observability in far communities. They basically compensated for the decline that otherwise would have happened as you move points of treatments further away. These signals really move that back up to saying, I have knowledge about what other people did, mostly in the direction of like, oh yeah, I know that person took the action. I saw it. So I think there's a question that I should probably take, and then I'm going to rush through the rest.
There's no question, Anne.
I thought something was popping up. Okay, sorry. So then I'm just for this, just showing you here the average treatment effects then that we are getting from the structural model. And the nice thing is the model gives us very similar treatment effects that we're getting from the structural exercise, even though, you know, we're restricting a bunch of things than what we're getting from the reduced form. Mostly these estimates are more conservative, meaning the differences that we're estimating now between far and close, given what we're allowing in the model in terms of variation, I mean, heterogeneity to introduce, is basically slightly smaller, the variation. And then what we can do is basically the structural model allows us to decompose the effect of the average treatment effects into what is driven by the social image returns, the signaling, and what is driven by the private incentive effect. And maybe to no surprise, we're estimating a large negative private incentive effect for the ink. So now what we can do now that we estimated the different parameters, we can think about the same exercise as before. What happens as we have a marginal change in distance? How does that affect take up? And we're going to have, on the one hand, as we know, we have the direct effect of distance on take up. But then secondly, we have the social multiplier object, which we're revisiting now. And it becomes a little more complicated because not only do we know from theory that changing take-up can change the marginal person, and therefore the expectations you form about those who take the action versus not. But also what I've just shown you in the data, what we learned is that distance can have a direct effect on the observability of actions. Now, social image returns are all about both of these components. They are about, well, it's okay if you think there's higher types of taking the action, but there's no point in that if I can't observe you. So basically what's happening is there's a horse race coming up about maybe the action is going to become more informative in the denominator about what type you are, as fewer people take the action and we're moving further away. But at the same time, as distance is increasing from our empirical data, we see actually actions become harder to observe in the way that people are learning in these campaign settings. And so therefore, in our model, it's not just the prediction going one way, given we're at low take-up levels, but at low take-up levels, it could be that based on stronger type inferences, you get a mitigating effect. But at the same time, if visibility falls by a ton, then the increase in distance could actually backfire in a sense that it actually reduces social image returns. So what we do in the paper now is we are estimating these social image concerns, these social multiplier effects compared to a benchmark. What you see, the gray or black line, like in the center of all four incentive conditions, is the world where you would assume there's no visibility. If there's no visibility, essentially you have a social multiplier of 1. And then we can think about what is happening in our incentive treatments. And I'm plotting you what is happening based on just the changes in type inferences. This is the red dotted line. So you can see if it was just about the type inferences, we would estimate a social multiplier that's less than 1, meaning the direct cost effect would be dampened because it's multiplied by 0.8 or 0.9. But the blue line is giving us the combined social multiplier effect. And as you can see in the control and calendar treatment, that is actually now greater than 1, meaning like the direct cost effect is going to get amplified by 1.2, given that we have the strong decline in observability. Whereas in the ink and bracelet treatment, given we have constant observability or even slightly higher, we get an even lower social multiplier. So you see it's sort of further falling in the ink and the calendar example, we're sort of between 0.9 and 0.8, by which the direct cost effect is going to be multiplied or reduced. Now, how do we think about this in terms of the optimal policy location of points of treatments? I'm showing you here the map of all eligible points of treatments we could have chosen in blue, the little triangles, and I'm showing you in black the dots of 144 communities that we wanted to serve with deworming treatment. So the way we're going to think about this now is the policymaker is aiming to achieve a certain level of take-up, but she wants to do that at a minimal level of resources. So concretely, she wants to minimize the number of points of treatment she has to place, but she wants to do that subject to achieving a certain target level of deworming. And subject to obviously every community, so communities are indicated by X here and Y is going to be the points of treatment. Every community has to be linked to at least 1 point of treatment and shouldn't be further away than 3.5 kilometers. We didn't want to extrapolate too far outside our experimental distance observation. And you see some expectation operators and whatnot here. This is all because what we're doing is we're letting the uncertainty that we're estimating in our structural model, we're using a Bayesian estimation, we're letting that propagate through this decision-making problem, meaning we're not just going to use one parameter point estimate. We're drawing from the posterior distribution of parameter estimates and going to do this like 200 times. So we're actually going to give you a point of treatment, like the median point I can report, but I can show you the interval, the optimal interval of points of treatments. So now what we can do, given we have the structural setup, we can basically say, hey, we want to think about different counterfactuals. Let's fix the private benefits in all of these scenarios at the control level. But let's think about how the optimal allocation would change as you change visibility, but also importantly, how does it differ when a policymaker has full knowledge about the social multiplier, the interaction between social image returns and these economic incentives, versus when she thinks, oh yeah, there are social norm concerns, people are going to respond to visibility, but I'm not cognizant that that is changing as I'm changing distance. I think that's just a static, like most experiments, we estimate some static social image concerns, not the dynamic change. And then lastly, you can also think about, well, most of the time, if you were to pilot this intervention first, you may do that at an individual level. What if you were to be oblivious in some sense and had just implemented travel vouchers to learn about people's response? If you had not taken into account any of these social image concerns. So this is the map again with the 144 points of treatments, how we linked it. And I'm just going to show you now, I'm running out of time, but essentially just doing the optimal thing, having full knowledge as a policymaker about these interactions. What that means is, as you can see, communities are now, multiple communities through these lines are linked to 1 point of treatment, meaning you can say from 144 to 107 points of treatments, you can connect more communities to 1 point. This further declines to 90 points of treatments as you are taking bracelet visibility instead of control visibility. And yeah, I just want to demonstrate, quote unquote, the mistake you would be making if you were not taking into account the interaction. Like, you know, there's social image concerns, but you don't realize how they change across distance. And so you would, for the control, you would underestimate how many points of treatments you need by about 7%. And for bracelets, you would overestimate it by 6 points of treatment, which is also 7%. And now the last graph I'm going to show you, when we're thinking about the spatial distribution of points of treatments, I'm showing you in green what was our experimental location, meaning like across distances between 0 and 3.5 kilometers, where did we sort of place points of treatment? So we were very naive about the distance, sort of a bimodal distribution. If you are in the control world with knowledge as a policymaker about these social image returns effects, then you would take into account that you sort of give people a double whammy. Not only when you make them walk further, they have a cost, but they're also going to lose social image returns. So you place most points of treatments close. People are assigned their closest point of treatment. You have very little mass at far. But when you're in a world of bracelet where visibility is constant, you can see you can leverage this mitigation effect, meaning that in the far distances, social image returns are going to compensate you for the direct cost effect. And so what you're going to do is you're going to stop. Some communities are not going to be walking very close. They're going to have actually a very far point of treatment assigned to them. So to wrap up, I think in this paper, what we sort of a proof of concept where we want to show that there are meaningful interactions between what we otherwise might think as logistical factors in health, or like economic incentives and social image returns. Consistent with economic theory, we find that these social image returns actually increase at lower take-up levels, like in our context with deworming, but that visibility might actually be affected by travel distance and can reverse these effects. And lastly, I would want to say that, in order to get at these interactions, it's really important to, do experimentation at scale. And then, what we learn here can actually meaningfully lead to the expansion of health services. As I've shown you, you could actually set, for some communities, treatment points further away. Thank you so much. I think I totally ran out of time.
Thanks a lot, Anne. This was great, and I'm very glad it's recorded, such that more people can take note at a different time of their convenience.
Sure.
I think I'm not sure whether there's still time for 1 or 2 questions.
I still have some time if that's the question.
Unfortunately, we do have to cut it. We can go 1 question at maximum, but we do have to cut it shortly. So just 1 quick question.
Just looking around whether anyone else still has a question. Otherwise, I have 1 quick one.
Go.
David, go ahead.
Has. No, I have a small one. I will email.
Okay. Now, I was just curious, and because now what you're looking at is sort of social image in the context of people's children, right? Not themselves. I was just curious whether you have any sort of prior idea about when it comes to people's own image, or so when it's sort of about their own. Can you say
Sorry,
something?
so this was about their own image.
Yes, but I mean the reason why they do deworming is because of their children, mostly, you said earlier, right?
No, so sorry if this was clear, I rushed through a lot. I think that they actually have little understanding in this context. This is similar to what I first saw in terms of the externalities and who they would be doing it for. Certainly when they're thinking about school deworming, they would be doing it for their children. They would want them to get dewormed. But when I said to you, people are thinking what we have from the qualitative data inferences like health conscious or responsible person, that is related to you as an adult taking care of your health, or you participating in a civic campaign for your health. So these are actually estimates that I would say, given the understanding of externalities and how people think about this, we can mostly think about this as adult health behavior, not linked to you're doing something good or bad for your child, like in the case of childhood vaccines, where I've done work.
Okay, thanks.
You're welcome.
Good.
Thank you so much for having me.
Thank you very much, Anne. Thanks a lot.
Of course.
Great.
Welcome. Bye. Bye.
Bye.
Bye.